Hello students and good morning. So now I'm doing class for class 12 science. So today's topic is the new topic, that is standard integrals. And in the last online class we finished integration by the method of substitution. So today we'll start this standard integrals. Okay. So we can write down the date also. So today's date is 12th September 2020. So the time now is 9 a.m. Now let's start this standard integrals now. So there are 6 standard integrals in this case. In this chapter, for these standard integrals, there are 6 standard integrals that you should know. So let us write down 6 standard integrals now. So let us write it here. So it is standard integrals. So standard integrals. Okay. So first standard form is number 1 is integration of dx divided by x square plus a square is equal to, here dx with respect to x, that is x is the variable and here a is a constant. So this is the first standard integral. So its formula will be 1 upon a tan inverse x upon a plus c. This is the first standard form. You should know it, you should memorize it. When you practice it, then you can easily write down the formula for this integration, but you have to practice it. Okay. So now number 2, integration of dx divided by x square minus a square is equal to, now there is minus sign here, x square minus a square. Okay, a is constant, x is the variable. So its formula will be 1 upon twice a log within mod x minus a upon x plus a mod sign closed plus c. This is the second standard integrals. Okay. Now number 3, integration of dx divided by, now it is a square minus x square. Okay. So now here a is constant. This is the first term, that is a square minus x square. So it's a standard integral. What is its formula now? Its formula is 1 upon twice a log within mod a plus x divided by a minus x plus c. That is the formula for number 3 standard form. Now let us write down number 4. Integration of dx divided by, now the expression is under square root, that is x square plus a square is within square root, that is within root x square plus a square is equal to, now number 1, it is same as number 1, but the expression is under square root. So what is dx divided by root over x square plus a square? Its formula will be log within mod x plus root over x square plus a square mod sign closed plus c, and here the log base is e. So log within mod x plus root under x square plus a square base e plus c. This is the fourth standard form. Now number 5, integration of dx divided by within square root, now it will be x square minus a square, which is equal to, what is this formula now? Its formula is same as number 4, but within square root there will be x square minus a square, which is equal to log within mod x plus root over x square minus a square mod sign is closed, then plus c, here the base is e, right? So this is the 5th standard form. Now number 6, integral sign dx divided by, now it will be root over a square minus x square, which is equal to, what is the formula now? Its formula is sine inverse x upon a plus c. So these are all standard integrals, and these are also very, very important. Okay, so you should memorize all these formulae. That is, there are 6 standard integrals. Okay, so in number 1, number 2, number 3, the expression is free from square root here. But in number 4, 5 and 6, the expression is under square root, which is in the denominator. So accordingly, you have to use the formula. So what is number 1? Integration of dx divided by x square plus a square. This is the first standard form. Its formula is 1 upon a tan inverse x upon a plus c. Next, number 2. Integral sine dx divided by x square minus a square is equal to 1 upon 2a log within mod x minus a upon x plus a mod sine close plus c. And then third standard form, integral sine dx divided by a square minus x square is equal to 1 by twice a log within mod a plus x upon a minus x plus c. And then what is fourth standard form? Integral sine dx upon root of x square plus a square is equal to log within mod x plus root under x square plus a square mod sine close, the base is e plus c. And what is the fifth standard form? Integration of dx divided by root over x square minus a square is equal to log within mod x plus root under x square minus a square mod sine close, the base is e plus c. And the sixth, that is the last standard form, is integral sine dx divided by root over a square minus a square is equal to sine inverse within bracket x upon a plus c. So these are the 6 standard integrals that you should remember it. You should memorize it. Okay. So now let us prove it. So now let us prove number 1. That is proof of number 1. So that is, we will prove that integral sine dx divided by x square plus a square is equal to, what is the formula? 1 upon a tan inverse x upon a plus c. Now let us prove it. Okay. So therefore I is equal to, let us write down the left hand side, dx divided by x square plus a square. So how can you evaluate this integral? So in this case, the power of x is 2, directly you cannot integrate it. If the power of x is 1, then we could have integrated it directly by taking log, right? But the power of x is 2, there is different method now. So in this case, you have to do the trigonometric substitution. I told you about it, isn't it? If there is x square plus a square, you put x is equal to a tan theta. I told you about this substitution. If it is x square minus a square, then x is equal to a sec theta. If it is a square minus x square, then you should put x is equal to a sine theta. I think you know it. So if you have x square plus a square, you put x is equal to a tan theta. If it is x square minus a square, you put x is equal to a sec theta. If it is a square minus a square, you put x is equal to a sine theta. But here it is x square plus a square. So what should you put for x in this case? So you put x is equal to a tan theta. Okay. So let x is equal to a tan theta. So let us put x is equal to a tan theta. Okay. Now differentiate. So differentiating both the sides. So differentiating both the sides with respect to theta. So therefore dx by d theta is equal to, a is constant. What is the differentiation of tan theta? It is sec square theta. Now let us get the value for dx. What is dx is equal to? A sec square theta d theta. So now we have got the value for dx, which is equal to a sec square theta d theta. So let us put the value here in I. So therefore I is equal to integration of, what is dx? It is a sec square theta d theta divided by, what is x square? a tan theta whole square plus there is a square. Is that clear? So now you have to simplify it. So let us simplify the denominator now. Or I is equal to integration of a sec square theta d theta divided by a square tan square theta plus a square. Is that clear now? So let us take common from the denominator. What is common? I is equal to integration of a sec square theta d theta divided by, what is common here? A square. Within bracket we have tan square theta plus 1. Is that clear? So now here you can cancel this a and square will be cancelled. Okay. Now in the next step we can write here, or I is equal to, you can take the constant term outside integral sign. Here 1 upon a is constant, you can take it outside. So 1 upon a integration of, in the numerator we have sec square theta d theta divided by, now in the denominator what is the formula for tan square theta plus 1? You know that 1 plus tan square theta or tan square theta plus 1 are the same expression. So its formula will be sec square theta. You know that, isn't it? So cancel this one. So 1 by 1 is 1. So I is equal to 1 upon a integration of d theta, or I is equal to 1 upon a into, this is, what is integration d theta? Theta plus c. But you have to get the answer in terms of x. You have to put the value for theta. So from here you can get the value for theta. So if x is equal to a tan theta, what is tan theta is equal to? It is x upon a. And what is theta is equal to, from here it is tan inverse x upon a. So we have put here x is equal to a tan theta. So what is tan theta is equal to x upon a. What is theta is equal to tan inverse x by a. So let us put it out here. So I is equal to 1 upon a into, what is the value for theta? It is tan inverse x upon a, then plus c. So we have proved number 1. So I think you have understood it. So you can copy it. Now we will prove another one, another formula. So now we will do next proof, that is formula number 2 and formula number 3. They are same type of formula. So I will do number 3, this number 2 will be a homework. You prove number 2 formula at home. So this is your homework. Okay. So formula number 2 will be homework. You prove this formula number 2. Let us prove here formula number 3. So proof of 3. So proof of 3. That is, you have to prove integral sine dx divided by a square minus x square is equal to 1 upon 2a log, and within mod a plus x divided by a minus x plus c. Okay. So now let us prove it now. So let us write here I is equal to left hand side. So I is equal to integration of dx divided by, it is a square minus x square. So in this case you may do trigonometric substitution or you may factorize it. You know that a square minus x square can be factorized using a square minus b square. Then after factorization you should convert it into partial fraction. You know how to convert it into partial fraction. In differentiation, I told you about partial fraction, isn't it? Let us use the method of partial fraction in this case, okay? You may use x is equal to a sin theta trigonometric substitution also. You can do it at home, okay? So let us do here partial fraction method, because this denominator can be factorized, okay? So let us factorize it. I is equal to integration of dx divided by this is a plus x into a minus x. So these are the factors, that is 1 upon a plus x into a minus x is a fraction, and you can convert it into partial fraction now. So how will you convert it? So let us assume 1 upon a plus x into a minus x is equal to capital A upon small a plus small x. You may write here plus or minus, okay? Capital B divided by second factor a minus x. Suppose this is number 1. So here capital A and capital B are constant. Now you have to find out the values of capital A and capital B, and you have to put it in 1. So this type of fraction, that is a upon a plus x plus capital B upon a minus x, is known as a partial fraction. So let us find out the value for capital A and capital B. So or now it is 1 upon, this is a plus x into a minus x is equal to, what's the LCM now in this case? It is a plus x into a minus x, right? So numerator now becomes capital A into small a minus x. You know that, how to simplify it? Plus capital B into small a plus small x. So I hope you have understood it. So here this LCM will be cancelled. So what are the remaining terms? 1 is equal to capital A into small a minus small x plus capital B into small a plus small x. So from this relation, we can easily find out those values of capital A and capital B, which are constant here. So in order to get the value for capital A, you have to make this second term 0 by putting the value for x. Because x is a variable, you can put any values of x. Here is constant, okay? If you put x is equal to minus a minus a will be 0. That is second term will be 0. You can easily get the value for a, right? So let us putting x is equal to minus a. If you put x is equal to minus a, this second term will be a minus a 0. Second term is 0, isn't it? So therefore it is 1 is equal to a within bracket a. So this minus into minus plus a, we are putting x is equal to minus a. So a plus a, and this term will be 0. Or what is the value for capital A is equal to 1 upon 2a. I think you have understood it, okay? So now in order to get the value for capital B, you have to make this capital A or this first term as 0. So how can you make this first term as 0? You have to put x is equal to a. X is the variable. You can give any values to x. But if you put x is equal to a, this will be a minus a 0. This term is 0. You can get the value for B. Okay. So putting x is equal to a here, what do we get? This 1 remains as it is. 1 is equal to this capital A into small a minus small a, that is 0. You will get only B, that is it will be a plus a, right? So therefore what is capital B is equal to, in this case, 1 upon 2a. That means we have got both the values of capital A as well as capital B. Both are 1 upon 2a. So let us put those values of a and b in 1. So let us write here, putting the values of a and b in number 1. Let us put the value for number 1. Let us put the values of a and b in 1. So what do we get? So let us put the values of a and b in 1. So therefore 1 upon a plus x into a minus x is equal to, what is capital A? 1 upon 2a. 1 upon 2a divided by what? A plus x. Then plus, what is capital B? 1 upon 2a, isn't it? So write down 1 upon 2a in the numerator divided by, in the denominator we have a minus x. Is it understood now? So we have converted this fraction into partial fraction. So now we will put this partial fraction in I. So therefore I is equal to integration of, actually this is 1 upon a plus x into a minus x. So what is this value? What is this partial fraction? Let us write it here. Instead of this fraction, let us write down this partial fraction. Okay. So it is 1 upon 2a divided by a plus x. Is that clear? Next, plus, what is the second term? 1 upon 2a, a minus x, second bracket close, dx. So now, if you can convert it into partial fraction, we can easily separate this integral sign and dx also, so that you can do the integration. Okay. So therefore I is equal to, now let us separate the term, and constant term you should write it before integral sign. Okay. So it is 1 upon 2a integration of dx divided by a plus x, plus again 1 upon 2a is constant, integral sign, dx upon, this is a minus x. So I think you have understood it. Okay. Or I is equal to 1 upon 2a into, now since here the power of x is 1, you can take this algebraic function as x. So what is integration of dx by x? It is log x, but here instead of log x it is log of within mod a plus x. Is it clear now? So whole divided by 1 should be there. So 1 से कसरी आयो भन्दाखेरि, we have assumed a plus x as x to integrate it. Again you have to differentiate the function which is assumed as x. That is, you have to differentiate a plus x with respect to x, which is equal to 1. So in case of integration you have to divide it by 1. But since it is 1, you don't have to write it. Is that clear? Similarly, plus 1 upon twice a into, this is also the power of x is 1, a minus x can be taken as x. So what is integration of dx by x? It is log within mod x. So it will be log within mod, what is x here? A minus x. Whole divided by, what will you write whole divided by? Here also a minus x is assumed as x to integrate it. Okay. Again you have to differentiate the function which is assumed as x. That is, a minus x is also to be differentiated. So what is this differentiation? For a it is 0 minus 1. 0 minus 1 is minus 1. So it should be divided by minus 1. Then what do we write here? Plus c. Is that understood? In case of integration you have to divide it by minus 1. But in case of differentiation you have to multiply it by minus 1. So this is the case of integration. So we have divided it by the differentiation of a minus x, which is minus 1. Is that clear? So let us simplify it now. Or I is equal to 1 upon twice a log within mod a plus x. Now this is plus into minus, minus 1 by twice a log a minus x mod sign closed plus c. Right? So what is common now? You can take common here. I is equal to 1 upon twice a common log within mod a plus x minus log within mod a minus x mod sign closed, third bracket closed, plus c. Okay. Now you know these properties of logarithm. Log a minus log b. What is the formula? Log a minus log b? Log of a by b. Or I is equal to 1 upon twice a log within mod. What is a by b? It is a plus x divided by a minus x mod sign closed plus c. So you may write here base c also. or you don't have to write that base e. Okay, it doesn't matter if you don't write the base e. Okay, so you may write here base e also. So this is the formula. So it is proved. So I think you have understood it. You have understood this proof of number 3. So similarly you can do number 2. So number 2 is your homework. Okay, so you can copy it. Now we will do another one. So now we will do proof of number 4 and number 5. So now in number 4 and number 5, the expression is under square root, which is in the denominator. So in this case you have to do the trigonometric substitution. So let us do number 5 out here, and this number 4 will be our homework. Okay, so let us prove this number 5, and this number 4 will be your homework. Okay, and you can do this number 6 also. Number 6 is also your homework. So these are all trigonometric substitution. So I'll give you the hint for number 4 and number 6. In question number 4, you have root over x square plus a square. So whenever there is plus sign here, you should put x is equal to a tan theta. And for this number 6, there is root over a square minus x square. So minus x square is the second term here. You put x is equal to a sin theta. For number 4, you have to prove x is equal to a tan theta. And for number 6, you put x is equal to a sin theta. Okay. For number 4, you have to put x is equal to a tan theta. And in order to prove formula number 6, you put x is equal to a sin theta. Is that clear? So let us prove this number 5 here. Proof of 5. So let us prove it. What is the formula? Integral sine dx divided by root over x square minus a square, which is equal to, what is the formula in this case? Log x plus root over x square minus a square mod sign close. The base is e plus c. So you may write here base e, log base e, log base e, and so on. Okay. So now let us prove this formula number 5. So therefore let us write I is equal to left hand side. What is the left hand side? Integral sine dx divided by root over x square plus a square. Now let us prove it. Okay. Now in this case, let us do the method of substitution. So if you have x square minus a square, and if you are to do the trigonometric substitution, you put x is equal to a sec theta. Let x is equal to a sec theta. Okay, let's differentiate it. So differentiating both the sides, with respect to theta. So it is dx by d theta is equal to, what is the differentiation of this? A sec theta? A is constant. Sec theta differentiation is sec theta tan theta. Is that clear? Now let us cross multiply. Or what is dx is equal to? It is a sec theta tan theta d theta. This is the value for dx. Okay. So what will you do in the next step? Let us put these values in I. So therefore I is equal to integration of, what is dx? It is a sec theta tan theta d theta divided by root over, what is x square? It is a sec theta whole square, then minus a square is there. Okay, now let us simplify it further. Or I is equal to integration of a sec theta tan theta d theta divided by within square root, it is a sec square theta minus a square. Is that clear? Now again within square root there is common a square. Let us take it common. I is equal to integration of, this is a sec theta tan theta d theta divided by within square root, what is common? A square. A square is common here, isn't it? So this a square is taken common, so it is sec square theta minus 1, right? So now let us simplify it again. Therefore I is equal to integration of a sec theta tan theta d theta divided by, now within square root you can write a square into, and now what is the formula for sec square theta minus 1? You know this formula. Sec square theta minus 1 is tan square theta. So let us write here tan square theta. Okay, so or I is equal to integration of a sec theta tan theta d theta divided by, what is square root of a square tan square theta? It is a tan theta. So here tan theta and a will be cancelled. You can cancel them. Or I is equal to, this is integration of sec theta d theta. This is only integration of sec theta d theta. So now what is the formula for integration of sec theta? So we have done this formula in method of substitution. What is the formula for integration of sec theta? It is I is equal to log within mod sec theta plus tan theta, mod sign closed, then plus c. Is that clear? So now, but you cannot keep the answer in terms of theta because you have to convert it to x. You have to write down the formula in terms of x. What is the formula? Log within mod x plus root under x square minus a square, mod sign closed, the base is e plus c. So you have to write down the formula in terms of x. Okay, you know what is the value for sec theta? Sec theta is equal to x by a. You can convert this tan theta into sec. So or I is equal to log, you can write base e also, base e within mod, you know the value for sec theta. What is the value for sec theta from here? Here sec theta is equal to what? X upon a. Let us write here x upon a plus, and you have to write tan theta in terms of sec. What is tan theta in terms of sec? You know the formula, root over, this is sec square theta minus 1, mod sign closed, base e plus c. Now let us put the value for theta, sec theta now. You know the formula for tan theta, isn't it? Tan square theta is equal to sec square theta minus 1. What is tan theta is equal to root over sec square theta minus 1. Now let us put the value for sec theta. Or I is equal to log within mod x upon a plus root over, what is sec square theta? It is x square by a square. Then minus 1, mod sign close, plus c, the base is e. Or I is equal to log within mod x upon a plus, let us simplify it. What's the LCM? A square. So this will be x square minus a square, mod sign closed, base e plus c. Here the base is e, right? Or I is equal to log within mod x upon a plus. Now the square root is in the numerator only, because what is square root of a square? Square root of a square is a, mod sign close, plus c, the base is e here. Or I is equal to log within mod, what's the LCM? A here, so it is x plus root over x square minus a square, mod sign closed, the base is e plus c. So I think you have understood it. Okay, so now in the next step, How will you simplify it? This is log of a by b, isn't it? What is log of a by b? You know log a minus log b, right? So you know this is in the form log of a by b. So it is log a minus log b, or I is equal to log of, what is a? A is in the numerator. That is your x plus root over x square minus a square minus log b. Log b here is log a. You can put it within mod sign also, because this should be always positive. Base e, then what do you write? Plus c. So I think you have understood it. Here the base is e. You can write here base is e. And you know that log a is constant always, isn't it? Minus log a is constant. Since c is already written there as constant of integration, you don't have to write log a. The constant of integration c लेखेको कारणले गर्दा चाहिँ यो log a constant हामीले नलेख्दा पनि हुन्छ, because this is log a is constant because it is free from x. Okay, so don't write log a now. So, or you don't have to write log a base e. So it is only log within mod x plus root over x square minus a square, mod sign close, the base is e, then plus c. So it is proved. So I think you have understood it. So we have proved this formula number 5. That is, it is log within mod x plus root under x square minus a square, mod sign closed, the base is e plus c. Okay. The similarly you can prove this number 4 and number 6, and these are your homework. Okay. अब यो 6 स्ट्यान्डर्ड इन्टिग्रल चाहिँ तिमीले राम्रोसँग याद गर्नु. अब म तिमीलाई प्रब्लम देखाउँछु. यही 6 स्ट्यान्डर्ड इन्टिग्रल्स को एप्लिकेसन. So now let's do this problem now using this standard integrals. Okay. So now we'll do this question, that is from exercise 6b, page number 362, from the section 2 mark section from the book Higher Mathematics for Class 12 by SND. So let us do this integration. The question is integrate, that is question number 1, integral sine dx divided by 4x square plus 9. So now in this case we will directly use the standard integrals but not the trigonometric substitution. We can use direct standard integrals. So you should know all these 6 formulae, right? So let us write here first I is equal to integration of dx divided by, this is 4x square plus 9. अब हामी यसलाई standard formula लान्छौं. So you should always remember that the coefficient of x square should be 1 always. Then only you can convert it into standard form. So if the coefficient of x square is positive 1, then it's okay, or coefficient of x square is 1, it's okay. But if the coefficient of x square is not 1, you have to make the coefficient of x square as 1. Okay? But here what is the coefficient of x square is 4. So you should make it 1. So you have to take 4 as common to make the coefficient of x square 1. Okay. So therefore I is equal to integration of dx divided by, here 4 is taken common, within bracket it is x square plus 9 upon 4. So you have understood now, we have taken 4 as common. So within bracket we have x square plus 9 by 4. Is that clear? Next, which is constant here that you can take outside, it is 1/4 integration of dx divided by. Now you can convert into standard form. Here x square is x square plus, what is a whole square here? This 9 by 4 should be converted into whole square. So this is your 3 by 2 whole square. Is it understood now? So which standard form is this one? So you always remember that you have to make the coefficient of x square always 1 in order to convert into standard integrals. Is that clear now? So next, now this is the standard form. Which standard form is this one? This is the first standard form. Here x is x only. What is the value for a? It is 3/2. So we can use standard form number 1. Okay. So what is the formula for standard form number 1? It is 1 upon a tan inverse x upon a. So let us write it here. Or I is equal to 1/4 constant. You have to write it. Now you have to write down the formula. So this is in the form dx divided by x square plus a square. Here x is x and what is a? It is 3/2. What is this first standard form formula? 1 upon a tan inverse x upon a. So it is 1 upon what is a? It is 3/2. Then what do you write? Tan inverse. What is x upon a? What is x here? X only. Divided by what is a here? It is 3/2. So this is 3/2. So we have integrated it. So you have to write down plus c. Understood now? Let us simplify it. So 2 1s are 2. This is 2 2s are 4. Or I is equal to this is 1/2 3s are 6. So it is tan inverse. So within bracket, when this denominator 3/2, if it goes up in the numerator, it becomes 2/3. So it is 2x upon 3 plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we will do the next question. So now we'll do the next question, that is question number 2. So let's do this question now. Question number 2. Okay. So it is integration of dx divided by 2x square minus 5. So here also you have to make the coefficient of x square positive 1. So or I is equal to integration of dx divided by, it is 2x square minus 5. So I already told you that always make the coefficient of x square positive 1. So here also you should take 2 as common. So or I is equal to integration of dx divided by 2 is taken common here. So it is x square minus 5/2. Or I is equal to which constant is taken outside? 1/2. Integral sign dx divided by, let us convert into standard form. This is x square minus, what is a whole square? It is root over 5 divided by root over 2 whole square. So I think you have understood it. Here the value for x is x only, and what is the value for a? It is root 5 by root 2. So which standard form is this one? This is dx upon x square minus a square, which is the second standard form. So what is the formula? What is the second standard formula? If it is integration of dx by x square minus a square, what is the formula? 1/2 a log within mod x minus a upon x plus a. So let us write here, or I is equal to, this is half is constant, you have to write it. Half त तिमीले लेख्नै पर्छ constant. अब 1/2a into 1/2 into what is a? Here a is root 5 by root 2. Twice a, 1/2 a. 2 into a is root 5 by root 2. Okay. Then what do we write? Log within mod x minus, what is a? X is x only. What is a? Root 5 by root 2. It is root 5 by root 2 divided by, in the denominator you should write x plus a. What is x plus a? X plus root 5 by root 2 mod sign closed plus c. Now just simplify garnu ta. You have to simplify it now. So root 2 1s are root 2. 2 like what the times? Root 2 times. So or I is equal to, this is 1/2 root 10 log within mod in the numerator as well as in the denominator. What's the LCM? Root 2 is the LCM. And that LCM will be cancelled. And what do we get? You will get x root 2 minus root 5 divided by x root 2 then plus root 5. Mod sign closed plus C. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now we'll do the next problem, that is problem number 3. So let us integrate this integral. That is, number 3 is integral of dx divided by 16 minus 25x square. Here also the coefficient of x square is 25. You should make it 1, okay, by taking 25 as common. So therefore I is equal to integration of dx divided by 16 minus 25x square. Okay, so let us make the coefficient of x square 1 here by taking 25 as common. So I is equal to integration of dx divided by, here 25 is taken common, within bracket what do we get? It is 16 by 25, you know that, minus x square. Is that clear? So now you should convert into a standard form. So constant term is taken outside. Which is constant term here? I is equal to 1 upon 25 integration of dx divided by 16 by 25. Let us convert it into whole square. So it is 4 upon 5 whole square minus this is x square. So here what is the value? For a it is 4 by 5, which is the first term. And what is x? X is x only. So this is your dx divided by a square minus x square, which is the third standard form. So in this case we have to use the third standard form, that is integration of dx divided by a square minus x square. So the formula is 1 by twice a log within mod a plus x upon a minus x. So let us use the formula in this case. So therefore I is equal to 1 upon 25. You have to write down the constant term. Now use the formula. 1 by 2a. What is 1 by 2a? 1 by 2 into what is a here? It is 4 by 5. Then log, what is the formula? A plus x. What is a plus x? Here a is 4 by 5, isn't it? A is 4 by 5, and what is x? X plus x divided by a minus x. What is a minus x? 4 by 5 is a and minus x is minus x, mod sign closed, plus c. Is that clear? So now here you can cancel these. 5 ones are 5, 5 5s are 25, right? Or I is equal to 1 upon 5 2s are 10, 4s are 40 log within mod. You can take the LCM both in the numerator as well as denominator. Here 5 is the LCM in both the numerator and the denominator, and that 5 will be cancelled. So after simplification you will get 4 plus 5x divided by 4 minus 5x, mod sign closed, plus c. So this is the final answer. So you can copy it. Now we'll do the next problem. Now we'll do question number 4. So you have to integrate this integral of, in the numerator, x into 1 minus x square divided by 1 plus x to the power 4 dx. So how will you do this integration? So let us first write I is equal to integration of x within bracket 1 minus x square divided by 1 plus x to the power 4 dx. So you cannot directly use your standard integrals because in the numerator it is given as x into 1 minus x square. So let us simplify the numerator now. Or I is equal to integration of x1 x minus x into x square x cube divided by 1 plus x to the power 4 dx. I think you have understood it. Okay. So let us separate this fraction, right? Or I is equal to integration of, let us separate this fraction now, then only you can easily integrate them. So it is x upon 1 plus x to the power 4 minus x cube divided by 1 plus x to the power 4 bracket closed dx. So I think you have understood it. Okay. So what will you do in the next step? Let us separate the term. So let us separate integral sign and dx also. Integral sign, this is x dx, x into dx, dx divided by 1 plus x to the power 4. There is minus sign, integral sign x cube dx divided by 1 plus x to the power 4. Now, how will you integrate these two integrals? Now, for the first integration, there is x and in the denominator we have 1 plus x to the power 4. So, how can you integrate it? So, you know that differentiation of which function is x? It is x square. What is the differentiation of x square? Actually, it is 2x. 2 is a constant, you can manipulate it. त्यो 2 constant हामी यताउता गर्न सकिहाल्छौं तर x स्क्वायर को डिफरेन्सिएसन चाहिँ हामी x ल्याउँदै छौं x आउँदैछ सो x टु द पावर 4 लाई हामी पहिला के लेख्छौं x स्क्वायर होल स्क्वायर सो इन दिस केस यु शुड ह्याभ द नलेज अफ बोथ मेथड अफ सब्स्टिट्युसन एज वेल एज स्ट्यान्डर्ड इंटिग्रल्स इज दैट क्लियर सो differentiation of which function is x? It is x square. So you have to make this x to the power 4 as x square whole square. Okay. So this is the first integral. So how can you integrate this second integral? So what is the relation between 1 plus x to the power 4 and x cube? You know differentiation of 1 plus x to the power 4 is, for 1 it is 0, it is 4x cube. 4 is constant, you can manipulate it. Okay. But we are getting x cube. So in this case, we can directly put z is equal to 1 plus x to the power 4. So I think you have understood it. So let us write it as I1 and I2, right? Or I is equal to, let us write first one as I1 and the second one as I2. Clear? So let I1 is equal to, let us find out the value for I1 first. What is I1 is equal to? I1 is equal to integral sign x dx divided by 1 plus x to the power 4. Now in this case, first of all, you have to do the method of substitution. You cannot directly write here the standard integrals. Is that clear? You know that x to the power 4 can be written as x square whole square and the differentiation of x square may be x, isn't it? So let us write here, or I is equal to integral sign dx x dx divided by 1 plus, this is x square whole square. You have to make it x square whole square because the differentiation of x square is 2x. Okay. So let z is equal to x square, right? So differentiating both the sides, with respect to x. So therefore dz by dx is equal to 2x, right? So let us do cross multiplication. What is dz is equal to 2x dx? But here in the numerator we have only got x dx. Let us take 2 to the left hand side. So dz upon 2 is equal to x dx. So I think I've understood it. So what is I1? So I1 is equal to integration of what is x dx? It is dz by 2 divided by 1 plus what is x square whole square? 1 plus what is x square whole square? It is z square, right? And 1 can be written as in terms of 1 square, or I1 is equal to, which is constant here that you can take outside? It is half integral sine dz divided by 1 square plus z square. Now this is the standard form. This is x square plus a square. Instead of x there is z, and instead of a there is 1. This is the first standard form. So what is the formula? Or I1 is equal to half is constant, you have to write half into, this is dx divided by x square plus a square form. Instead of x there is z, and instead of a there is 1. What is the formula? 1 upon a tan inverse x upon a. What is 1 upon a here? 1 upon 1. This is 1 upon 1. Tan inverse, what is x upon 1? What is x upon 1? It is z upon 1. X here is z divided by a is 1. Then you have to write plus c. So let us put the value of z, or I1 is equal to half tan inverse within bracket. What was z actually? Z is equal to x square. So you have to write x square plus c. Is that clear? So I think you have understood it. So this is half tan inverse within bracket. What is z here? It is x square bracket close plus c. So that is your I1. So let us get the value for I2 now. What is I2 here? I2 is equal to integration of x cube dx divided by 1 plus x to the power 4. So let I2 is equal to integration of what is here? It is x cube dx divided by 1 plus x to the power 4. So now in this case we cannot use standard integrals, because in this case differentiation of the denominator is the numerator. So we can use the method of substitution as we have done in the previous chapter. Okay, so what is the method now? Let z is equal to 1 plus x to the power 4. It is let z is equal to 1 plus x to the power 4. So differentiating both the sides with respect to x. So it is dz by dx is equal to 4x cube. For 1 it is 0. What is the differentiation of x to the power 4? It is 4x cube. I hope you have understood it. So you can do cross multiplication. Dz is equal to 4x cube dx. Okay. But in the numerator, in I2, we have got only x cube dx. So let us take this 4 to the left hand side. So, or this is dz by 4 is equal to, this is x cube dx. So we have got the value for x cube dx, right? So what is I2 now? So therefore I2 is equal to integration of, what is x cube dx? It is dz by 4 divided by, what is 1 plus x to the power 4? It is z. Understood now? So here we can take constant outside, integral sign. I2 is equal to 1/4 integral sign dz upon z. It is integral sign dz upon z. Or I2 is equal to 1/4 log within mod z base e then plus c. So this is the base e, right? This is the base e. Now we can put the value for z. What is I2 here? So therefore I2 is equal to 1/4 log within mod, what is the value for z? In this case, z is 1 plus x to the power 4. 1 plus x to the power 4. Here the base is e. Then what do we write? Plus c. But this is not the answer. I2 is not the answer. You have to get the value for I. So put those values of I1 and I2 in I. Okay. So let us write here, since I is equal to I1 minus I2, or I is equal to, what is I1? What was I1 actually? It is half tan inverse x square. Don't write plus c here, because one c will do, right? Only you have to write only one c. So let us write half tan inverse x square. Don't write c here now. Then write down I2 minus, this is minus 1/4 log within mod 1 plus x to the power 4, log within mod 1 plus x to the power 4, mod sign close, the base is e. Then you have to write plus c. So 1c, that is constant of integration, will do. Okay, so this plus c is a constant of integration. The last ma constant of integration लेख्दा फेरि तिमीले दुईवटा c लेख्नु पर्दैन, त एउटा लेख्दा पनि भइहाल्छ. So this is the final answer. So the answer is, what is I is equal to? It is half tan inverse within bracket x square, then minus sign 1/4 log within mod 1 plus x to the power 4 base e, then plus c. So this is the final answer. So I think you have understood this question. You have understood this answer also. Okay. So this much is for today. The आज हामीले जति पनि problems हरु गर्यौं, we have done standard integrals. Try to memorize it. Try to understand all this proof. You do the homework also, and you do revise all the problems that we did today. So in the next online class, we will do more problems on this standard integrals. So this much is for today.